Ladies and gentlemen, welcome to our panel under the Value-Driven Innovation Scientific Program aiming harnessing science and technology for growth, employment, economic success, and personal well-being cross-cutting approach. Today's session is dedicated particularly to the prestige of scientific expertise versus technology demand, parallel routes for a common innovative purpose. It is organized by both Resources and Climate Change as well as Responsible Research Environments Task Force of the Policy Working Group belonging to the Marie Curie Alumni Association. The agenda of the panel contains the following blocks of introduction part, the presentation of the speaker's profile, the context of the presentation's short advancement, as well as the discussion part afterwards. The possible questions from the audience can be included at each point of the session in the chat box. They will be all addressed after. The session will be finalized with a short resume about the most essential common points of the discussion. The prestige of scientific expertise versus technology demand session is aimed at every audience expertise or interested in the natural and artificial resources sustainable worldwide efficiency. This panel discussion aims to comment and promote a new economic growth and sustainable paths regarding the security of value chain supply for material resources at the upcoming end of 2020. These material resources concern within this thematic context either raw, primary materials, waste streams, or resultant byproducts. The invited today experts represent the civil and material engineering, waste management and transfer of technology key backgrounds and will comment on their perspectives and insights regarding the common future strategies, recommendable paths within European and worldwide contexts. The first speaker of the session, Mrs. Agnieszka Łukaszewska, graduated in civil engineering from the Gdańsk University of Technology and structural engineering from the Chalmers University of Technology in Sweden. She's the head of a research and development department in Fasada company, which is a construction small-medium enterprise that also actively participates in European research projects. It is based in Poland. Agnieszka has more than 15 years of experience in development and management of the research projects from 6th and 7th frame programs and Horizon 2020 related to the energy efficiency and sustainability. In the same time, she has been involved in the market deployment of new solutions for energy efficient and green retrofits and new constructions. She was also a chairman of the steering committee of the Polish Strategic National Project Integrated System of Reducing Energy Demands of Buildings. Welcome. Is currently a postdoctoral research fellow at the Institute of Electronic Structure and Laser Foundation for Research and Technology ELAS in Greece. She's a PhD graduate from the Department of Physics of the University of St. Andrews in UK, and she originally received both her bachelor's and her Master of Science degrees with distinction from the Department of Physics of the University of Crete. Also in Greece, she undertook multiple projects in laser interaction and division research area with a particular emphasis on laser beam shaping, nanotechnology, laser materials processing, material science, and biophotonics applications professional specialization. Her postdoctoral research includes work for almost 4 years as a research and development scientist to develop new methods of lithography in nanoscribe company in Germany, and also as a laser development engineer during the 2 photon absorbers for biomedical applications project in Amplitude Systems in France, funded by Marie Skłodowska-Curie Initial Training Network. Her research has been published in more than 15 publications in peer-reviewed journals and conference proceedings, matching more than 540 citations according to Google Scholar. Welcome. And the third speaker of today, Mrs. Ernesto Guades, is currently working as Marie Skłodowska-Curie found postdoctoral research fellow at the Technical University of Denmark. He obtained his PhD in structural engineering at the University of Southern Queensland, Australia, in 2013, and Master of Engineering in Earthquake Structural Engineering at Saitama University in Japan in 2006. His main research interest is in structural repair and rehabilitation of buildings and historical structures and development of innovative and sustainable construction materials. He published several journal papers and actively participated in international conferences on topics of fiber reinforcement, polymer composites, and geopolymer concrete. Welcome, Ernesto. And the organization of the present session, Mrs. Lidia Natalia Trusilewicz, holds a PhD on building materials from the Technical University of Madrid and Master of Science on Environmental and Chemical Engineering from the West Pomeranian University of Technology in Szczecin, Poland. She has been involved within the construction science sector since 2005, balancing both academic and industrial or research and development, European public and private sectors, and thus receiving numerous insights and interdimensional perspectives. At present, she is a subject matter expert and a project monitor of European Commission on several interdisciplinary key areas considering engineering and circular economy. Since 2017, she is an honored representative of the Maria Skłodowska-Curie Action Program. Currently, she also leads both the Responsible Research Environments and Resources and Climate Change Task Forces of the Policy Working Group in the Marie Curie Alumni Association. The panel discussion is preceded by short presentations of the speakers regarding sustainable management of natural and artificial material resources, exemplifying how these ideas can potentially be put together into practice. The presentations you will see make a reference regarding two thematic areas. The first one is digitalization, automation of buildings, introducing new sustainable and cost-effective technologies to optimize energy consumption and comfort of end users and customers. And the second area is dedicated to eco-materials, zero emission and zero waste technological solutions, as well as the use of materials with ergonomic resource requirements and lower or no environmental burdens than the traditional practice so far. I hope you will enjoy the panel. Agnieszka, the floor is yours.
Good morning, everyone. In my presentation, I will try to answer for a very difficult question: how successfully introduce cost-effective technologies to optimize energy consumption and comfort of end user in construction sector. I'm working in SME that performs the renovation and construction of the building envelopes. Since 2009, next to the traditional construction business, we are participating actively in a research project. Till today, we have participated in 7 research projects, and the 2 new are coming very soon. Our role in the research projects is mainly connected with the installation of the prototype solution on the real buildings that need to be renovated. It means that we are facing the real problems that are not possible to anticipate in the laboratory context. Often, the prototype is very good in the laboratory, but when it needs to be implemented on the real building with old and not straight walls and people living inside the flats, the problem comes. So innovative solutions need to be adjusted to the real needs of the people and technical requirements of the buildings. On this slide, you can see example of our demonstration work. I would like to present one of our recent projects called P2Endure that was funded under the Horizon 2020. This project is a very good example of energy efficient deep renovation. The main goal of the project is to promote evidence-based innovative solutions for deep renovation based on prefabricated plug-and-play system in combination with on-site robotic 3D printing and building information modeling, acronym and called BIM, demonstrated and monitored at 10 real projects in 4 Go clusters with EU replication potential. Our demonstration building, you can see here on the photo, is a public kindergarten located in Gdynia in Poland that was constructed in 1963. The building had a very low thermal performance. The goals for the renovation were to reduce by 60% net primary energy, to achieve cost reduction of at least 15%, renovation time reduction of 50%. Our deep renovation should guarantee high indoor environmental quality, and the technologies used by us need to have high replication potential in Europe. Because our building does not have actual as-built documentation, first step was to perform 3D laser scan, and based on the created cloud point, we have developed building information model. Next step was to perform reliable energy simulations in order to choose the best renovation scenario that will be accepted by the investor. In order to assess the indoor air quality, we have installed inside the building 2 devices developed by our project partner Politecnica della Marche from Italy, called Comfort Eye. The device allows to monitor the level of carbon dioxide, temperature, and particulate matter pollution. In Poland, the temperature drops in autumn and winter, and then the air quality deteriorates. The heating season opens the season for smoke in towns and villages. Air pollution is a growing problem here. Although some steps have been already taken, in many places air quality exceeds the permissible level. Therefore, the municipality of Gdynia, owner of the demo building, was interested in checking if any pollution from the outside gets to the building. The monitoring is conducted before and after renovation works. This slide shows the renovation works done by Facada team. The building was renovated with multifunctional facade panels that were developed in the project. The facade panels were partially prefabricated, what decreased the renovation time by 50% in relation to traditional insulation works. Time analysis supported the planning process and enabled to better plan the renovation works. Now, I would like to present the lessons learned during these last 10 years of participating in research projects. My first comment is related with the cooperation with the academic community. In our history, we had difficult communication with Polish research and technical organizations. From our perspective, they prefer to perform traditional testing and then to work on the innovative solution. The academic community needs to be open-minded and think out of the box. That's why mobility of researchers is so important. One aspect is the mobility between the countries, and another between the academia and the industry. Communication between the industry and academia is a key factor for increased professional competences. The biggest barrier in implementing innovative green construction components and energy system is their initial purchase cost, often 3-4 times higher than the traditional available on market solutions. This is the reason why many building owners, especially owners of the residential buildings, decide to use cheaper and better known solution. This is valid especially for the renovation. Therefore, in order to convince people to use innovative and more expensive products, very good idea are governmental help and financial incentive, such as tax reductions, low interest loans, or subsidies. Cost optimization is a very big innovation. We should not forget about that. Very important national document that can boost the implementation of energy efficient green solution is the National Energy Policy. Next issue is the long-term responsibility for the installed innovative building components that is very often on the shoulders of the SMEs. This aspect is often overlooked in the research project. Innovative production and materials that were developed within the research project often don't have required technical approvals and certificates. And all buildings owners requires warranties. It means that the research project ends, the company installed the solutions still need to bear the cost. Existing buildings often has old, not updated paper documentation. Good answer for that is 3D scanning. Nevertheless, there is a need for automated transition from the 3D scanning and cloud point to building information model. This process should be considered as one task. The requirement to use a BIM during the project must come from the investor. In the beginning, public administration. Smaller architect's offices are not used to work with the building information modeling and are not aware of the benefits. Therefore, training on BIM and use of BIM open standard is highly recommended. On the market, we can see lack of manufacturing and mass production of reliable plug-and-play buildings components. There is a need for development of robotization and automatization, if prefabrication for acceleration of deep renovation. Last but not least, I would give my feelings about the first Polish strategic project on reducing energy demands of buildings. This was a first national strategic project funded by the National Center for Research and Development with budget around 6.3 million euro. The project started in 2010. The main drawback was that only RTOs could participate in the project and no industry partners were allowed. There was also no continuation of the project and no major link with the European project on energy efficiency and sustainability. What is also, I think, a big drawback of this project was that no demonstration components were introduced during the project. That's all. Thank you very much for hearing my presentation. And this was a little bit of giving you my Polish East European context. Thank you very much.
Thank you very much, Agnieszka. Areti, the floor is yours.
Thank you. So good morning, ladies and gentlemen, and thank you for having me in this panel discussion. First, I will discuss, the first topic is science for the benefits of all that I want to mention. So how an idea, the way from an idea to the product. So how an idea can become a product as actually or a solution. But first of all, I will make an introduction also from my background. I obtained both my diploma in physics and my Master of Science in microelectronics and optoelectronics from University of Crete here in Heraklion in Greece. And then I moved to Scotland, to University of St Andrews, and obtained a PhD in laser physics. In Scotland, I also worked as a research assistant during my postdoctoral studies. And then I moved to Bordeaux, to France, as a Marie Curie Fellow, and I worked in Top Bio ITN project. And after that, I moved also to industry in 2015 in Germany, in Nanoscribe GmbH, which is a small medium enterprise company based on high resolution 3D printing using 2-photon polymerization laser-based technique. After that, I just came back to Greece. And since then, I'm working as a postdoctoral fellow here at the Institute of Electronic Structure and Lasers at Foundation for Research and Technology in Heraklion. And I made a small short visit, for 3 months in Doha, in Qatar, at the Texas A&M University, working at laser processing of materials for energy and biomedical applications, carry out simulations, write literature surveys and technical papers and reports. So my 3 domains of research are shown here, just briefly to go through them. So first, I have an expertise in laser beam shaping, harnessed and sculptures light, as we call it, with novel beam shapes with unique properties that can be applied to many exciting applications. Then we test light matter interactions with 2D and 3D deposition of materials using 2 different laser-based techniques. One is the 2-photon polymerization and the other one is the laser-induced forward transfer technique. And third, we apply the other 2 scientific fields for high-resolution 3D printing, where we do 3D fabrication with high throughput and scalable 3D lithography and highest precision. So when we make a connection between science and academia, we have to look back into doctoral training. And as we discussed last year in the conference in Germany called Forces and Forms of Doctoral Education, there are some challenges in doctoral implementations. So I wanted to mention a few here in order to gain the best scientific background. So I listed 6 of them. So there is a scholarly community. So the PhD student needs to understand the threshold concepts of the domain. Managing the supervisor needs to have a positive student-supervisor relationship, starting the thesis, owing the time, have a strong time management. This is a skill gained during the PhD studies. So there are 2 here listed as feeling lonely or stress. So you need to work alone or with limited collaborations and overcome any initial excitement that is there. So some proposals that we see that can be there to overcome any challenges in doctoral training is to present your work overseas. So to attend conferences abroad is a key part of achieving the national standing, identify the biggest conference in the field and submit applications to present papers. It's a good suggestion then to pick journals and publishers carefully, publish your work in places that will achieve a worthwhile audience in international recognition, and create research connections, securing fellowships, teach at the research facilities at universities abroad, and participate on professional associations like, for example, the Marie Curie Association and voluntaries. So coming back now, after this scientific background that you gain as a PhD fellow or a research, there in a very recent paper here, we can see that what it needs to be done, or what is the path from an idea to become a solution or a product. So first of all, you need to research and answer a question. So there is a generation of an idea. You need to find findings and answers to these questions. So to collect data. To collect data, you need to design, to test the idea. You have to publish it, even patent your ideas, and then you make the link with the market, with the industry that is there, in order to have at the end a product or a solution out in the market. So 5 steps that I will show you as a takeaway message, and what has been discussed is there are 3 main questions. First question is what do we know already about the subject? So a new idea, I want to highlight this text here. So a new idea may generate many services and solutions for the present problems, like infection disease and unsolved hypotheses. And also the second question that comes in mind is, what does your purpose theory or idea add to the current knowledge available, and what benefits does it have? So even a Nobel Prize laureates that have won prizes not only have given always a new idea, but most of them have used pre-existing ideas to solve human unsolved problems and issues. So you have to think what this idea adds to the current knowledge available. And last but not least, the third question is that among numerous available studies, what special further studies is proposed for testing the idea? So established business centers is a suitable model in academic industry institutes that must be accelerated to promote new ideas. The ways of implementing models of collaboration between those two who produce science and those who are active in industry must be clarified. And the take-home message of the idea and a solution or a product are these 5 steps here for turning your invention idea into a product. So first of all, you have to document it, discuss about it, research it, make a prototype, file a patent, and market your invention. And the second topic is a little bit more applied that I wanted to discuss. So it's the environmental impact of 3D printing, because we are in the panel of prestige of scientific expertise versus technology demands here. So a question is, where does the 3D printing technology stand on the green side? At this table here, as you see, there are a few differences of processes in 3D printing and traditional manufacturing. So regarding the forming method, the 3D printing is that additive manufacturing other than subtractive, the most of the traditional methods out there. As materials in 3D printing community, we use powders, filaments, and tapes rather than block, bars, and plates. It is the efficiency there for 3D printing is higher. The production of waste is much less than the traditional manufacturing methods. The building time is much less also. The cost is higher because it's a new technology. There is a lot of development to be done there. The life cycle is shorter. We don't need skilled workers, so we just with a couple of days of workshops, anyone can use a 3D printing. And the suitable applications that we see there are making prototypes in complex shapes. So to mention then the cleaner side, so just a few advantages of 3D printing. The biggest one is that the 3D models can be made lightweight, so that we can reduce energy consumptions of the machine that they are fitted in. And I will show you a case study in the next slide. The 3D printing uses a large amount of plastic, which is recyclable. Actually, the most of the plastic that is used there is recyclable. 3D models can be created almost everywhere. So there is no need for transport, costs, emissions associated with this, etc. And 3D printings can be used to build varied parts without any changes to the setup of the machines. The less greener side is that the 3D printers consume a high amount of electricity in comparison to the standard machining tools, something that I discussed previously in the table that I showed you. And the reason behind that is that the laser or the heat technology used to fuse the materials requires a large amount of power. But just to have a case study example, here is a recent one in 2016 where energy and emission saving potential is shown as a case study of lightweight aircraft components that they were 3D printed. Excuse me. So the greener side is that in this case study, researchers at Northwestern University used topology optimization to reduce the weight of a metal aircraft bracket. This reduced a 65% weight reduction, so from 1 kilo to 380 grams. So the researchers estimated that by changing just these components and optimized 3D printed parts like this bracket, as I just said, the overall aircraft weight could be reduced by 4 to 7%, with fuel consumptions lowered by as much as 6.4%. So we see the greener side highlight, as I said before. And the final predict, which is in process, it's not something that we don't currently working on. Here in the lab, work a lot on materials development, for example. So there will be a lot of material available for 3D printing, like glass, ceramic, plastics. There are a lot of SMEs out there, a lot of spin-off companies. And we see a lot of potential for new materials, like, for example, the PLA bioplastic that requires less heat energy to melt and can significantly print the energy consumption, reduce the energy consumption of 3D printers. There are several experiments also to use the wood pulp as an adhesive binder that needs less energy than melting plastic. And it's exciting because it's exciting in this community to see that as an example, for example, from solar cinder that uses solar energy to fuse sand into glass. This came at the news just a couple of years ago. And some examples, it's only the beginning, we think, of making 3D printing greener. And we're looking at the trend to advance 3D printing technology. We hope that the 3D printers of the future will use 100% renewable energy and locally available materials out there. And so that's all from my side that I wanted to discuss in this panel this morning. And thank you very much for having me.
My presentation is a little bit different compared to the two previous presenters, because this one is about how waste materials can be used and application in structural part, which is my research expertise. And I'm talking about now the how a geopolymer concrete can be used specifically on rehabilitations of concrete or buildings and other historical structures. Now we know that we usually use cement as binder in concrete. For example, this one, when we would like to make piles or maybe a concrete structures, we use cement as the base material. However, there are issues of using the Portland cement, and when we manufacture cement, it requires large amount of burning of limestone, and it actually emits significant amount of carbon dioxide. And when we produce 1 kilogram of cement, that also produce 1 kilogram of carbon dioxide. And in total words emission, carbon emission, it corresponds to around 5% of the total emission, which is actually need to be addressed. And also the productions of cement also consumes large amount of natural sources, and we don't know, maybe 50 years or 20 years from now or 100 years from now, the productions will be will be affected because we don't have resources anymore. So there's a problem with sustainability. And therefore, and if we would like to have a green, sustainable, and resilient infrastructures, which we are now moving into what we call smart cities, it is important that the product or the buildings that we are building are actually into this one. And now, accordingly, for us to be having smart structures or smart cities, we need to apply what we call the principle of low greenhouse gas emission. And also there should be almost a zero waste, and we need to have it in circularity order. Another one also is the the structures that we will building should be can withstand against extreme conditions. We have the typhoons, we also have earthquakes, and we also have different conditions which needs to be considered. And now the challenge is to look for OPC alternative, and we sometimes consider decarbonation in construction industry. But in my part, I'm looking into the materials that can substitute, or at least it can augment the use of OPC in construction industry. And recently, a geopolymer was considered as a new construction material, although it is still new, and the application is still new also. And so research are actually into this kind of material. And what is a geopolymer? So actually, a geopolymer is an inorganic aluminosilicate compound. They are actually rich in silicon and aluminum. And this is an example of a concrete, a geopolymer concrete, which is made of, we have also the water, we also have the activators, we also have the aggregates, and just like the same with concrete, only that here for this particular product, instead of using water, we use activators, and instead of using cement, we use the GGBS, that stands for ground granulated blast surface slags, and the other one is pulverized fly ash, and the other one is metakaolin, which are the common precursors of geopolymer. And here are examples of the precursors in producing geopolymer. We have the fly ash, and fly ash are, they are the byproducts of in coal station, power stations. Although now the challenge for fly ash using is because of the greener rule, especially in Europe. So the 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 uh, the availability of fly ash becomes now a concern. And another one also is the ground granulated blast furnace slags, which are byproducts of steel industry. And this fly ash and GGBS are basically byproducts. That means it is actually available. And when it comes to metakaolin powder, which is located on the extreme right, this is made from metakaolin. And to form this powder, we need to Celsius. And if you have 800 degrees Celsius, this is much lesser compared to Portland cement, which needs around 1,800 degrees Celsius. So I mean to say this is also this is a little bit not really into energy consumed material when it comes to developing of this material, and also it's not uh, providing such electricity. And recently also they are using rock quarries which are from mine tailings, and so they also started this using now as part of a geopolymer concrete. And in order this to be activated, then we use the common activations of this one for fly ash, metacholine, slag, and combinations of this one. Now, the common activator is coming from sodium silicate, a combination of sodium silicate and sodium hydroxides. And those are the material part. But now I'm considering on the structural part. Now, if we consider the advantage of this compared to our Portland cement, now you will see here that the strength of concrete is almost similar or comparable, or actually lesser than compared to that of the geopolymer concrete. This means that we can use this one structurally. Another one also is this geopolymer concrete is performs better in fire, be compared to that of cement because of their ceramic-like properties. Another one also, it geopolymer also has shown to have a good bond strength with opposite concrete, which is actually one of my motivations why I use this in rehabilitations. And also, geopolymer concrete has lower creep, meaning to say it has lesser crack. That means that if you use this in tanks, then this is suitable also because it has less seepage within compared to that of a plain Portland cement made. And the other one is the other feature of this material is that it has superior performance compared to traditional concrete in terms of sulfate attacks resistance. That means it can stand in sea or in corrosive environment compared to that of cement. Now, there are already applications of geopolymer concrete in new structures. For example, this one in Australia, they use geopolymer concrete in building this University of Queensland Global Change Institute, which is located in Brisbane. And they use most of the panels or most of the girders. They use slabs. They use this geopolymer concrete. And also in US, they use also geopolymer concrete, this material in building in a temple which is located in Chicago, USA. And also this has been also used in retaining walls, and also they are used in boat ramps because they are less corrosive. So this can be applied in marine or in seawater fronts. And also they are used as sewer pipes and culverts, and also as pipes, because if you put this underground, it is exposed to corrosion, and therefore if you use this material, this is a little bit corrosive resistance. And they are also used in bridges. And my applications actually is more on rehabilitations. Those are new materials, but this one is on more on rehabilitations. Now, this material has actually potential in rehabilitations of existing structures now. For example, if you would like to increase the capacity of the building, or increase the service capacity, then we can use this material. And also, if your buildings or historical uh, structures is being corroded or deteriorated, we can use this one also material here. For example, in Italy, uh, they have spalled cover, concrete cover corroded, and also this building is subjected to fire, and also there are damages uh, in pier, which is actually on as part of the bridge. And also during earthquake, we need also to rehabilitate our structures. For example, this happens around 6.5 magnitude earthquake happened in my country, in which you can see here the destruction that was made. Now, if this happened, then some of the structures will be totally demolished, but some of them need to be rehabilitated. And that is not also an excuse also, because it also happens in Europe. For example, this one, You have earthquake that happened I think this is in Albania, 6.4 magnitude, and also in Italy and part of Turkey, which is actually exposed. So with these motivations, I consider this as my topic when I applied for a fellowship in Marie Curie, and so this is now what I'm doing at DTU. So what doing now is actually to develop some material which is basically coming from geopolymer, and then I tried to optimize them and then apply them in a concrete or in masonry structures. And then finally, after this, is that we can come up with some codes or maybe some result that can be proposed for codes that will be used in the industry as well as for practicing engineers. And I already have initiated some of the activities. I have meetings. I also have some workshop conducted way back when I went to as a visiting professor, and then we also do some collaborations with regards to other applications of this, and also have some visited with industries and talk about them and give them the potentials and other applications of their products. And also I presented some of the results in during the conferences which I've attended in Spain and in Romania, talking about this and talking with some industries on how this material can be streamlined as part of the RB products, and basically that can also be improved for further applications. And I think that's for my presentations, and hope thank you very much. And if you want to contact me, then this is my email address, and this is it. Thank you.
Thank you very much, Ernesto, Areti, Agnieszka, for your very nice presentations. Let's start the discussion part between the speakers. Perhaps for the first line, we could comment something about this meeting of the private and public sector that was widely commented, especially by Agnieszka, and I'm sure that Ernesto and Areti represents the academic part. We are about to conclude the 10-year strategy or smart, sustainable, and inclusive growth after 10 years, which was fixed to be finalized. Who wants to start?
I can start. I think it's very important that for the researchers, it's important to move between the countries. So the East Europe is also attractive and creates attractive potential for them to come. And that they see the benefits going to the industry, but also opposite, that industry see the benefits of having the researcher in their own premises, that somehow it has an impact on later on their daily business, yes? Because in general, industry works for the money, and we should not forget about that. So somehow I think it's very good for the researchers because they see how the industry works, what are the real needs, and how they can implement their ideas. So I think both industry and research, they can both benefit really a lot. And I think we really should pay attention on this aspect, especially in East Europe, in Nordic country, as Sweden, for example. This is normal. Like every PhD or a lot of PhD or master thesis even is done for the industry, but here not. And I think really the benefits, it's enormous. So for me, we should go in that direction, and everybody should be aware of the benefit and somehow maybe in the beginning even forced to that by the government and create very good opportunities. This is my thought.
Thank you, Agnieszka. I'm sure that this is a particular maybe Ernesto wants to join the discussion about it.
Yeah, actually, that is also true because what happened is we need to immerse ourselves into the industry. For example, in my case, what I have done is uh, I have contracted some of the companies which can partially collaborate with me, and then some of the existing materials that we have, for example, I can use that tailored to what the research I have. And so by doing that, at least we will be sharing with some of the results, as well as it can also provide some benefits to them, because of course the product that coming from them can be optimized, and also it can also be extended to other applications. So it is important that while you are working in the academy, you need also to extend yourself to others, especially from the industry.
So yeah, the connections must be made along the different sectors. especially when preparing this new researchers generation. What are your experience regarding your own products? Maybe Areti can start.
Yes, so regarding the Marie Curie networks, like the ITN networks that I'm familiar with, and also we are participating in a co-fund here in the Institute. These are excellent opportunities for mobility of researchers. So you can travel to different laboratories and also have secondments in different industrial partners. And in this way, you create research connections, and also you learn how to do application-driven research. So you learn how to do applied research. When you are just when you spend your time only in academic labs, so sometimes the purposes are a bit different, the reasons behind the research. So you want to publish more, you want to publish your research, but you don't usually do applied research. So these networks are excellent opportunities to create this kind of you learn about the needs of the market from big players in the field. You represent then the consortium in overseas in big conferences. You attend these conferences. So you are having the big picture of your research. Also the applied research, new ideas, new solutions. And you learn how to do those. So that's what I wanted to also to show in my presentation. You learn how to do it through time management, open-minded research, things like that.
Ernesto, you represent the other level of the Marie Curie Skłodowska Action, which is the co-found fellowship. What are your experience regarding this topic?
Yeah, because this one, actually, this co-fund is you have to propose for your personal proposal, and then fortunately it was approved, and so you have to do it. I mean, say independently, but it doesn't mean that you need to be solely working on yourself. But what I did is just I need to contact industries which are located in Denmark, located also in Sweden, and even in France, to relate their products, existing products, to what I'm doing now. And so by doing that, I am immersing myself into them so that my result could also be applicable to them. And on part of that, I also presented in conferences this product, and I am collaborating with some other researchers with common interest. And by doing that, we will be able to conceptualize a proposal which is related to the interest that we have, and by that one, we will be able to tap also the industries. And so although this one is very challenging because you need to, let us say 80% of the proposals will be done by yourself. And so you really need the supervisor. For instance, in my case, I have supervisors that also help me in collaborating, especially that I'm still new in Europe, and that really makes sense because of his help.
I understand. Areti, a question regarding your presentation. You've mentioned somehow, I would name it work-life balance problematics. I think a lot of research advancement regarding the new solutions, new products, process or systems are actually in practice carried out by PhD students. So could you comment on how can you see this balance from your personal perspective? Could you advance with your competences? This advance was what kind of speed it has? What is exactly the? I mean, would you could you? Will you were you able to face different supervisions along the way and maybe some issues caused because of that? I understand we are all institutionals and perhaps also the publishing process can be affected by different supervisions in this research careers. Could you comment on that?
Yes, of course, and thank you for bringing this up, because it's a very interesting topic to discuss when we are talking about PhD training in academia. The time management issue is very strong there, I have to say. So in my case, I always tried to have a positive management with different supervisors. And I think this is key, the role of the supervisor on this work-life balance to have during your training. In academia, you can always work to spend a lot of time in the lab in order to obtain your results. And this is something you learn during your secondment, during your training. And again, here it's a very good suggestion, the mobility and the consortium and the partners there. So if you go to industrial partners to make some secondments and some visits there, or even some discussions, as Ernesto proposed, with key players in the field, you learn with the different schemes. So you learn how they spend the time into different aspects, because you're not, that's the way you gain the experience. You're not experienced enough as an early stage researcher to plan your research accordingly by yourself, because we are saying that we want to make application-driven research and application-driven plans, but we don't know how much time we need to spend to materials development, to test these materials, and so on. And then you don't want to end up to work 12 hours per day in the lab by yourself, because for sure you will have some work-life problems there. So this is something that I learned. I was lucky enough, I have to say, and also through this participation that I had in different institutions, through this positive supervision, through this positive relationship with my supervisors and the industrial partners. With the R&D, between the R&D teams, when I worked in Manuscript in Germany, we were just 30 people there in the company and 11 people in the R&D team. So we had a very strong relationship between us, and we learned how to make this time efficiency, this time management efficient.
I understand that we are talking about not only the hard competences, but we are talking actually about the developing the soft skills as well along the research processes. And I'm sure that it's somehow always regulated by the interest all these entities you comment had on the topic of your PhD and the topic of your researchers. Do you have perhaps well, from your presentation it was obvious an experience in outside the European Union? How was it regarding these issues?
Yes, so outside the European Union, I work also in Qatar recently for 3 months as a visiting research associate, visiting lecturer there. So my experience there is that in these countries now, they make the working environment attractive. So you have an excellent infrastructure. and excellent working conditions there. So they respect a lot the work-life balance regulations. So my experience there was is very positive for a short term visit because of the climate change, I have to say, because of this of the country. It was excellent because if you can it needs you need to spend a little bit more time to adapt there, I guess. But we work-wise, we really like the place, and we have seen that by having an excellent working conditions and infrastructure is very attractive for young researchers to visit these departments and to set up labs for the first year students, to have some lectures there. So this was a very positive experience. This was a very, very nice experience indeed.
Mm-hmm. Thank you, Reti.
Thank you.
Agnieszka, you were commenting on the Eastern countries' reality somehow, especially regarding the attractiveness of these. Well, we have the Polish case study, Polish perspective here, very well pronounced. But I'm sure it is common for every country somehow from this block. Is it true that because perhaps 10 years ago these countries wasn't so attractive regarding the salary of the researchers, which I believe it's a very important factor as well regarding the precarity of the research careers almost everywhere. So I'm sure that at present it is not so important problem anymore. So what can we? How can we attract these open-minded researchers? These researchers that had this mobility in their careers to come to a country like Poland, Czech, Slovakia, to share their competences, to share their knowledge and their experience from the other countries?
A very good question, Lydia, but also extremely difficult to answer. For sure, one aspect can be the market potential, that we are still somehow a developing market. So the need for the implementation and the area for the implementation is wider, and you can try your ideas. Always when the market is in the preliminary stage of the development, you can really try a lot and you have a real chance, because on the well-developed market it's much more difficult to sell your ideas. Yes. So for sure, this is the one aspect that come to my mind. And what another can be, to be honest, I don't know, because also I think that this country are somehow matching the other better developed. Yes, in case of the salary, it starts to be almost the same. So I would concentrate on the chance that are giving the developing market, and that the market is not yet full and filled with all the ideas, but there is still a very high potential, and you can search where your research can be applied.
Mm-hmm. I understand regarding the possibilities, you would hire Areti or Ernesto competences to your company to have.
Yes, definitely. In general, we are looking
points
for open-minded person, and I have noticed from my experience that researchers, but in general workers who are traveling, who have been like traveling within the countries, and this really had very big influence on their attitudes and also on their competences.
Mhm. Ernesto, could you comment on perhaps these new spaces that can be used when foraging researcher come to a new country and can be even selective regarding the approaches that can be tested in the developing countries. I'm sure
Well,
your outside experience can be important here.
yeah, actually that is true, and I've been working, I've been studying in Japan and Australia and here in Denmark, and of course it's challenging because you are new to that place and you need to adapt. For example, when I did my PhD in Australia, I would say it's a little bit stressful because I really need to work, not only to work smart, but you need to work hard. And of course, upon coming to Denmark, which I think I would say the working environment is quite good, and so the knowledge that I have done, and also the attitude and the habit that I have experienced in Australia, I can easily adapt here in Denmark, because for example, in Australia, I have to go to the university around 7, and sometimes I have to return back around 12 o'clock in the midnight, just to do some experiments. And so when I came to Denmark, I was actually surprised because you have to work here around 7.2 hours a day. But honestly, I work here more than around 10 hours, sometimes 8 o'clock. Then I have to go home 7 o'clock. So those things, so I can easily adapt. And because of that one, and also that's also true when I did my master's degree in Japan, it's also the same within Australia. So it means coming in Europe, specifically in Denmark, is for me is I can actually adapt compared to maybe going back to Australia and also go to the Japan. So that's actually my experience with those universities and also countries.
Mm-hmm. I think that very often the part missed from this comments on the research careers paths, which is that for sure there are some personal reasons also that stands behind all these decisions, all these mobility decisions that are made, which is the paper of every human that trying to properly develop its own professional career. Changing the subject, I would like to come back to this intersectoral dialogue we commented at the beginning. How could we enhance this dialogue, especially regarding the common space for the discussion can be open standards solution may be very helpful here. And what about the open science? Who would like to comment on this? Agnieszka?
I can start, but I'm from the industry, so my point of view for the open science is a little bit different. That's probably yours, because in general,
the research community is divided in any case.
Yeah, I think the idea is very good, but you have to be aware that in general, industry really don't like to share with their ideas and developments and reveal them to others, because they really are afraid that something will be copied. I know companies that prefer to do really, they're not participating in a research project from Horizon or FP7, but they prefer to do research by themselves in order to have the knowledge for themselves. They don't need to share with anybody. They don't need to write any paper, produce any documentation. Everything is only for them. And also they can proceed in time as fast as they want or as slow as they want. So I know many producer of materials who decided not to enter to the project because of that, because they don't want to share the knowledge, or sometimes if they are in the project, they are really only, it's like, we will share the knowledge, but it's not a real share. Because also we have to be aware that the market, especially the construction market, and I think all the markets, the competitiveness is very big, yes. And we don't have only the competition from Europe, but I know also, for instance, from Asia, the companies that they want to be in the research project, European research project, participate, but in general to gain the knowledge, to take the data, to see what we are doing in order to do the same on their own market. So it's very difficult subject, because on one side I agree with you that open science, and it really then we can use and benefit all, yes. But it's not so easy for the industry. It's more complicated. It's easier, for instance, for us, as we are installers, we are SME, we are contractor, so we are not creating like a concrete IPR that we are like selling and we are afraid of revealing, yes?
Okay, so I understand that even the building information modeling system that is in progress all these years is limited because of all of this.
Yeah, we are here talking about using open standards like EFC from a long time, but it's also, if you really want to do that and apply that, it's quite complicated, because big names, big companies that are producing the software, to be honest, there are not so willing to have open standards, or just for the like very basic features. Yes, but if you want to make like a very deep analysis, concrete analysis with special problems, here with open standards, often you can have a problem. So, you know, it's like the book that have very nice cover, and the cover is like so pretty, but inside there is not a lot of text. It's similar here with the open standards. So it's really everybody somehow, or we need to be forced to use that, because it's very difficult to win with big sellers of the software that are earning really a lot of money. It's like a very big market. And I understand their approach, that they want to earn the money, and they are saying, yes, we will use open standards, but if you really want and you are into it, it's not working as it should. So still we have to work on that.
So I understand that the committee, this big project you commented, where the industry participants weren't allowed to enter somehow, wasn't what do you think? Was it why the academy was so protective with the implementation of the project? Perhaps because this is also, yes. I can hear Agnieszka. Maybe Ernesto, could you answer this issue?
Actually, in the case of this fellowship, we are obliged to have the open science, and so it is a must. And even before we are actually have to declare that the output that will be generating from this project should be available to the public. And now that is what I am doing. And also, fortunately, in my PhD, in my the publications, because I'm working it with the university, and although partially I work with the industry, so the outputs that I have done were actually published free. No, not really free, but it is published. Only that it actually depends on, for example, on the journals, because you have to pay if you would like this to be an open access. And if not, then it will be, it will be through a university that will be subscribing them. And what I notice is, if you are a PhD actually, and you are working with the industry, of course there is what we call confidentiality, and then you will be limited to publish your output. And what is more also stressful, if supposing that PhD required you to publish, now you are already in a dilemma. And I think I've known many PhDs who are on that scenario. They can't publish, but they are required to publish. And so it is, in that case, I think it is very important that the role of the supervisor should be there to guide the PhD, because PhD is dependent on the project, PhD dependent on the funding. And so if you have an effective supervisory team, then at least it can be sorted out.
Mhm. So I understand that the manager competences are very important here as well, to be combined somehow with what is the research part of every project. This is what we are talking about. This is another meeting point, very necessary, but somehow internal one, intra-institutional. Even Areti, some last word about the 3D technology that is actually very promising, especially regarding the interdisciplinary outcome that that can have. Could you comment about these possibilities, especially regarding the possible connection to the private public sectors at the same time? How does it work in your case?
Yeah, so in our cases, we work with 3D printing in micro scale. So we have collaborations with companies that they produce implants, and we make further developments for biomaterials. So we want materials to be more biocompatible and also biodegradable in a certain amount of time. So we see a lot of potential for what is called now is as bioprinting applications. So we see a lot of potential for this dimension, because we can control in 3D, we can control the shape, we can give this high precision at these objects, and we can make even complex objects that they mimic 3D scans, as Agnieszka showed, for example, 3D scans from buildings. We make 3D scans of human organs in order to mimic tissue engineering and to go for bio applications. But for 3D printing technology, it's really emerging a lot. So we see a lot of potential, and that's what I wanted to keep it a little bit more in general, this application, to show you what we mean about lightweight objects and how we can use this to reduce energy consumption. Of course, we have the less greener side that we use a large amount of power, because we work with lasers here to polymerize these polymer materials that we have. But we hope by the chemistry of these materials that we are testing a lot in the labs in this field, that we will eventually use less energy there, and we will be on the green side always.
Thank you very much, Areti, for this comment. I'm very happy to have all of you here at this panel. I would like to thank you for the very nice discussion, for the presentations. Agnieszka, Ernesto, Areti, it is a pleasure, really. Let's start the resume of the session. I hope to see you soon, another occasion. Thank you.
Thank you.